Now the energy carried per second through a particular area is what we call the intensity. So the energy carried through a particular area is not quite intensity, although it's pretty close. Remember, the intensity is a measure also of time. So it's not just the energy per area, it's the energy per second per area. That's why we measure it in watts per square meter and not joules per square meter. Joules are a measure of energy, whereas power is a measure of energy over time. We measure energy in joules and power in watts. So watts per square meter means the amount of energy traveling through a particular square meter per second. Makes sense, right? So we can see that this might be the square meter that we're looking at the intensity at. So using our equation for energy and dividing it by time, we can see that the intensity of a wave at a distance d from the source will be proportional to 1 over d squared. And of course there'll be a number of other constants, but we can ignore those for the moment. The important part is that the intensity is inversely proportional to d squared. That is, as d gets larger, intensity gets much smaller. This is called the inverse square law, because we have a square and it's inverse of intensity. Now it turns out that there are other mathematical and physical laws that have an r squared on the bottom, but if people are talking about the inverse square law, then they usually mean this one. Two stars in the sky, Sigma Draconis and 107 Piscium, are known to have an equal total power. That is, if you were at a distance of 1 meter from them, they would be exactly as bright. If Sigma Draconis is 18.8 light years away, and it looks 1.69 times brighter than 107 Piscium, how far away is 107 Piscium? So how do we answer this one? Well, we know that we must have to use the inverse square law. That is, I is proportional to 1 over d squared. But in this case, we have two stars for which the constant that we're multiplying the right side by will be exactly the same. So we can say that we have intensity 1 and distance 1, as well as intensity 2 and distance 2, right? Now, because the constant at the top here is going to be the same for both stars, if we divide one equation by the other, this constant will cancel out. So what we end up with is I1 over I2 equals, and this is going to be a constant over d1 squared, and here a constant over d2 squared. But how do we divide fractions? We invert and multiply. So that means that this will be equal to, invert and multiply, we end up with constant times d2 squared over constant times d1 squared, which means that because these two stars have an equal total power, this constant will cancel out. So now we have a very easy to read relation between the intensity of the two stars and the distance that we are from them. So that's a good starting point to try and answer this question. The intensity of Sigma Draconis over the intensity of 107 Piscium is equal to the distance squared of 107 over the distance squared of Sigma. That is Sigma Draconis, the star. Alright, so now we can rearrange this, because what we need to find is the distance of 107 Piscium. That is, this variable here. So we need it on its own side of the equation. We need to make it the subject. Rearranging, we can multiply both sides by the distance to Sigma Draconis and take the square root of both sides, and we'll end up with something that looks a little like this. And this will give us our distance to 107 Piscium. Now the question gives us the ratio of the intensity of sigma over the intensity of 107, It's 1.69. Luckily, it also gives us a distance. So this distance is given in light years, which means that when we get our answer will also be in light years. But given that the stars are so far away, we won't need to convert it to kilometers per hour, or kilometers or meters or anything like that. So, substituting in our values, we have 1.69 for the ratio of the intensities, we have 18.8 light years, and so, evaluating that, we end up with 24.4 light years, which makes sense. They have the same total power, but Sigma Draconis is a little bit brighter, so it must be a little bit closer. Therefore, 107 Pisces must be a little bit further away.